Welcome to this video on bringing an idea to a minimum viable product, or MVP, for an IoT project. Here is a look at the agenda for this video. We will cover the project overview, goals, architecture, and more. As a software engineer and amateur photographer, I wanted a way to take nature photos on a long road trip without constantly stopping. This project uses a Raspberry Pi to build an in-car system to automatically capture images, which I plan to use on a trip in July 2020. The main goal is to provide a do-it-yourself project for a Jeep owner. The system should take timed JPG images, utilizing time and GPS data, and save them to an SD card. It also needs the ability to manage, archive, and share these images, including archiving to cloud storage and sharing via an external IoT service. The hardware will be mounted for access by the driver or passenger. The camera will be mounted to the windshield, and the GPS will be mounted to the metal roof inside the vehicle. This diagram illustrates the system architecture and module communication, showing how the components interact within the system layout. Highlighted here are the commercial off-the-shelf or COTS items used in the system architecture. This section outlines the first part of the IoT component of the system. This slide further emphasizes the connection between the system layout and module communication aspects of the architecture. Here is a breakdown of the system modules, including the language used, and a brief description of each module's function, like the camera viewer, cloud storage access, and image manager. This is the initial boot sequence of the MVP. This dialog is the core of the application and does not require user interaction. The main application options, support options, system status, and power off button are visible on the screen. From left to right, the status icons display temperature, CPU utilization, Bluetooth and Wi-Fi configuration, and volume control. Make sure to properly shut down or eject devices before pulling out a USB device. The screen includes a virtual keyboard that can be toggled on or off. We will discuss the sharing and archiving features further in a moment. On the camera viewer screen, you can see the current image, adjust the capture frequency, and toggle saving to the SD card. You must remain on this screen for images to be actively captured to the SD card. The image viewer provides the ability to navigate through the images stored on the SD card, as well as manage them with options like deleting, zipping, and archiving. Google Drive is available for archiving images and zip files. You can also directly access Google Photos to upload your images. The system includes future options, shown by the overflow menu, for additional features that may be integrated later. It is crucial to always perform a proper shutdown of the Raspberry Pi before cutting the power to the system. This terminal view shows commands that can be executed via the Device Manager shell script, including options to edit source files, run the application, or set up the Raspberry Pi. This is a continuation of the MVP visuals for user reference. The IoT development utilized Firebase for posting data, establishing a connection to the real-time database. Even with open rules, data was not saving initially. This led to investigating why the data failed to persist in the database. A closer look at the Firebase setup revealed the issue causing the data failure. The problem stemmed from mixing up the two Firebase database offerings, Cloud Firestore and Firebase Real-Time Database. They have separate APIs, which can lead to confusion if documentation is cross-referenced incorrectly. Future development will focus on a mobile application and a web page for social interaction among Jeep owners. Considerations include a dedicated single-page application and cloud functions for file uploading and parsing. Here are the attributions for the materials used in this video. Key lessons learned include the incompatibility of mixing Python 2 and 3, the importance of good research, and understanding system architecture early on. The Raspberry Pi is an excellent platform for building IoT devices.